sorry about that. This episode's kind of long. Let's get right back into it. I said it will soon, so let's just make a class again, and we'll call it test.class. So now I think if we tried the same exact thing we did in main, we'll just copy this over. I think that'll be just fine. We can get out a rectangle. Now we'll just start onto this. That's not what I wanted to do. I guess it was. So I just copied it weirdly. Don't worry about it. So now if we try to, I guess we should also declare these things. Yeah, it auto-imported them. Don't worry about it. And who cares about string 3? So now we're calling rect3.width, which it's not visible. It's like we're looking all throughout here. We can't find it. Where is it? That's because now it's protected, not public, and not private. If it was public, this could use it. If it was private, it couldn't use it. But since it's protected, that means it's in this class. Rect is in this package. So everything in this package, when it's protected, it's allowed to use it. But since this is in a different package, it's saying, hey, no, you're not allowed to use this. So that is an example of protected. But if we change this, but yeah, so it's like, hey, no. But if we change this to rect2, since rect2 is a normal rectangle, and normal rectangles, their width, their coordinates, and their size are public. So rectangles are nice. We are not nice. Just saying. So, since this is going to be a two-part episode anyway, and this episode just started, let's go into other parts of this. What do you say? So we went over what is an object. We went over basically what's a class. You know, a class is how the file system is set up. And different classes, how you define certain object. Notice how we made a completely different class in order to make an object type, that is rect. Another thing we could do, for example, is we'll go over that later. Never mind. So yeah, you know what a class is, the files. You can, different objects. If you're going to make a new object, you normally need a different class. We'll talk about different ones in the future, but you don't need to know that. We talked about inheritance and how children can inherit different things from their parents. We went over modifiers. But one other modifier that we need, you might notice that when we, this is never used. I don't care. You might have noticed when we made the UID, it had a special identifier on it called final. Now we're just going to make a public static final integer, and we'll call it super width. Now this doesn't mean it's getting it from a parent. This does mean it's extraordinary. So super width. Now the reason it's getting an error is because since it's final variables, you can only declare them once, and it's on their name declaration. So we have to set this right now. So we'll call this 150. So this integer is going to stay this integer no matter what. No matter what, since it's final. If we try to set super width to something else, like 5, it's going to get an error, because super width is final. It's done, it's gone. You had your chance to set it, and you did. You set it, and you're not allowed to set it again. Now, also with final variables, you might notice I use the normal notation, because in Java, the variable names are important. Capitalization absolutely matters, and you normally want it one word, so you know the first word will be lowercase, since they prefer variables starting with a lowercase, and any other word will be with, capitalized, I mean to say. But with final variables, a good amount of people, I mean, some people still do final variables like this, but a good amount of people prefer final variables being all caps. So normally it would be like this, and to separate it, you would use underscore. So now, super width is that. Now, it's public, and it's static. Since, you know, having a final variable not static is, again, redundant, because you're never going to be able to change it anyway. So every time you call a different class, it's going to be the same, because you can't set it to something else. So static only makes sense for final variables. So now, we want things to be super width. Let's make this rectangle super width. just to use all capitals, so basically that's it. Final variables are used for that sometimes, but sometimes also used for when you're using switches, like when you need more than 2 default valuables for something, like sometimes you use true or false, you know, like, hey, should this be blah or blah? But sometimes you want to ask the question, should this be blah, blah, or blah? Such in the case in several things, but those are very advanced things, so we might just have to make our own. So let's just make a couple more public static final variables, and we'll say yes, no, and maybe. And we'll set this to 1, 2, and 3. And we're gonna move this to not main, because a lot of times you're gonna have these in variables. So now it's going to be an integer answer. I mean, obviously there's not going to be an answer contained in here, but it makes sense. You would put the answer somewhere else. Okay? So also we're going to have a string. Oh, we'll just put the string back in before the answer. Okay. So as an answer. So basically what you would do is you would call not main, since it's static, and you would say, yes, that is the answer. We don't know what the question is, but hey, that's the answer. And then you could put rectangle 5 will be maybe. I don't know what the question is, but maybe. Why are you a? I think those errors are just superficial. Yeah, it's just, maybe if we come back to it, yeah, those errors are gone. Okay, so they have 2 different answers. But how we would make that count, you would have a switch. You know what a switch is, I hope. So we're going to put it around answer. And you remember how when we did a case, we couldn't set it to like a variable like x. We can't because x isn't final. We could set it to a constant, since 4 will always equal 4. You can't change that. And final variables will always equals yes. So we do case yes, and we'll just system.out.println yes. Yes, please. Oh, silly me, I forgot out. And then, of course, we're going to break. Now we're just going to copy this 2 other times. Case no, and case maybe. Oh, all capitals. And we'll say, and you know, since we like being polite, we'll say, no thank you. Like a true gentleman. And then we'll say, maybe. I'll think about it. Just a little. So that means I like indenting these. Since, you know, I always like indenting things. Because they look weird when they're just flush with it. I'll also tell you, maybe later, how to edit your Eclipse stuff. But either way, yeah, there you go. So that means, depending on what answer you give it, it'll be something. So first it'll say, yes please, then it'll say, maybe. I'll think about it. Wait, error exists? Where? In test? I really don't care. Oh. Okay. We'll just set this to... It has to be any integer, so I'll just set it to 5. Normally, you do want to call the final, but since, you know, this isn't 5, it's not going to do anything. Because I don't want it to do anything. It would skew things. So we'll do that. Say, yes, please. Maybe. I'll think about it. And it print 100 because of that. We'll just comment that out. Yes, please. Maybe. I'll think about it. So you see that. So that's just used for different things, like when you're creating different things. Like I told you kind of about JFrames. No, I didn't. No, I didn't. JFrames are part of the Swing API, which is excellent. Is an API included in Java to really help with Windows and not Windows the operating system, but different windows, like creating different windows on your desktop. So it's good for that. And it creates a whole bunch of things to help you with that, and a whole bunch of other things for inside the window, like menus and lists and layered panes and dialog boxes and a whole bunch of different things. It's one of the best. That's one of the things that makes Java an excellent programming languages. Like in C++ and other programming language, it was fairly to very difficult to make GUIs and stuff, but Swing is like the master of GUI. So a JFrame is what you do to create a window. And a JFrame has different close events. Like you set it to something, like you do JFrame.setDefaultClose event, or setClose event, one of those two. And in it, you'd call a final integer from JFrame, and you can choose from more than 2 different ways. Normally, they do JFrame dot close on exit, which means whenever you press the X button in whatever corner you have your X button, depending on your operating system or preferences, that means it's gonna stop running it. Like, if you didn't set a default close, whenever you X out of the window, the Java program would still be running. So basically, you do that, so whenever you do X out of the window, the program will stop running, and, stop taking up resources and such. There are other ones, like close on quit, or there are several other ones. But since there's several of them, they use final to determine which one. Okay, so we went over all of those. I think we do have enough time to show you what an interface is. Ooh, and enums will be later. But don't worry, enums are epic, but you don't have to worry about them yet. So let's make an interface. Oh, I did not mean to press run. I meant to press add class. So now we're going to add a class called inter, since interface is already a class that lets you do an interface. Now, we don't want this to be a class. We want this to be an interface. Notice no errors, because this is going to be an interface. Now, what an interface does, it holds a bunch of empty methods. I explained what a method was when we went to rect. This is a method. In some programming languages, they call them functions or other things. But in Java, these are methods. They can return something, like in public static void main. This means main returns void or nothing. It doesn't return anything. But yeah, it returns. It's a collection of empty methods, which means you're like, hey, what can we use that for? You'll see. Like public void this. I think we can do. Oh yeah, because since this is an interface, all these methods are abstract, so they don't have a body, they just have a semicolon. Public void that. And public void, sure, I don't know, these names don't really matter. But basically, this is an interface that has these empty methods. So that means if we go to not main, we can do now you can only extend one class ever in another class. So you can't do like extends rect and rectangle. But with interfaces, you can extend as many as you want. So this implements inter. So that means this is getting an error, because when you implement an interface, you have to have all of these methods inside of it in order to do it. So we can just do add unimplemented methods, which is easy, but I don't like it because it makes it look ugly. But we can do public void this, and they have to have a body. Now that they're in something, public void that, and public void sure. There. Now that error is gone since we implemented all of these. Now you're like, why would you do that? But one very good thing are the interfaces that come with the Java API. You can create your own, and basically that means you can have a multitude of classes implement one interface, and that means those interfaces could like cross-call the implementation methods, the interface methods, I mean to say. So right now, since it implements something, we can call like not main dot, oh well, they're not static, so never mind. But either way, I'm going to show you something that it's also like another mini lesson, which is really awesome. You're going to love this. But implements key listener. Now real quick, we have to import it since it comes from java.auth.event, which is another package that folders below. Now we're going to automatically add the unimplemented methods, and you'll see now it has key typed, key pressed, and key released. You see what we're getting at? So we're just going to do add a system.out.println. So how we would do with this key listener, you can see @override just means you're overriding a class from in either an implemented interface or a parent class. Basically, if you take this away, it'll auto override it. It won't give you anything. I mean, if you look over here, it says, you know, overrides. Since it implements it, it automatically means it's overriding it. But basically, override is just a convenience. So say the key listener interface changed what their methods are called or what they accept. That means if it was @overrided, it would be like, hey, this isn't overriding a class because there is no class in the interface that's exactly like it. So you get an error because it's not overriding something, and that is like tells you, hey, now we can change it so it still works. If you didn't have @override and key listener did change, then you would have errors. Key listener is probably not going to change, to be fair. But when you're doing other programs like your own interfaces and stuff, then you can do that. And interfaces can also extend other interfaces, which means, you know, it includes, you can make a sub interface, like this could extend key listener. So this would be, it would include all the methods that key listener has plus these, but we don't need to do that right now. So basically, let's say when key is type, how you get the key. Now key event, now you get a key event whenever you press a key. So in order to get a certain key, you can do integer key equals e dot get key code. Okay. So now you're gonna say if key equals key event. We're accessing another final variable. There's a final integer for every key on your keyboard, and we're gonna use vk underscore h. So if you type a key, well, we don't want types, because you see there's three things. Whenever you press a key, it calls key pressed. Whenever you release a key, it calls key release, and whenever you like press a key and then release a key in a certain amount of time, it calls key typed. But it's not convenient because it's not always reliable. I mean, I'm sure there's instances where you want to use it, but not when we want to. So we'll do if that, then we'll do this, and we'll just copy this over. That is not what we wanted to do. I hate when it does that. There. But instead of printing out the width, we don't really care. We'll say, hello, everybody. I obviously spelled everybody wrong, but who cares? Then we'll say, else, if key equals vk dot space, we're gonna say every body jump. Now I think this might work. Let's test it. So wait. Okay. So we need to add key listener. Maybe this it doesn't extend anything. That won't work at all. I mean, there's certain classes that do have keyless. Okay, so just for yeah, we're going to import something else real quick. We're just gonna import that real quick. Don't worry about it. JFrame. just do jframe dot oh wait, no, frame dot, because yeah, frame dot set size. We'll just do a window that's 100 by 100. Of course, you know, I'm also teaching you how to separate window, not to put things in the window, but because we'll get more well in depth on how to use swing and GUIs in a much later episode. But so I'm not going to really be explaining what these do. So we're going to do add key listener this to add a key listener. Set visible, since I guess we want to see it. We don't need to see it, sure, but oh, we can't use this in a static context. I guess we'll just go rect. We'll just put this in rect. It doesn't really matter. What do you want this time? Frame.add key listener new main. I hope that works. Unreachable code. Oh, I might be doing something bad. Oh, I know that can't happen in a static context. I'm trying to figure out why the heck this is. Oh, yeah. Oh, wait, this is get rectangle. I did not want to do that. My apologies. I want to put this in rect itself. There, that should work perfectly. So now, if we do it, you'll see there's probably be a window in the upper left corner. Oh, wait, we need a... I forgot to set default close location. You see I X out of it and it's still running, so I'm just going to quit that. Go into rect. Do frame.set default close operation. jframe.exit on close. See, another final integer. Several uses. Now, if we run it, hopefully we get something productive. You see it, but now I press jump. You can. So right now, you know, if I hold down H, right now I'm still holding it down because as soon as you press it, it prints that off. If I let go, it doesn't do anything because we didn't put anything for key release. If I press space, it says that space space H H H H. Then we can X out of it, and you can see it actually closed out of it. Okay, that shows you what an interface is. I mean, there's a whole bunch of other useful interfaces from Event. Like, there's mouse listener, mouse motion listener, mouse wheel listener, and a whole bunch of other listeners and events that we'll go over in a different episode. But basically, I think this two-part episode included a lot more than I wanted it to, because I didn't actually want to be... Well, yeah, it included a lot more than I wanted it to, but I went over a lot of the concepts of object-oriented programming languages. Since I think we have a little bit more time left in this episode, I'm just going to take a quick discussion in that Java, as you may know, as you should know, is an object-oriented programming languages. Now, there are many other orientations in a programming language should. Like, there's function-oriented programming languages, which in very long ago, not very long ago, but a while ago, you know, in all of the very old programming languages, such as MS-DOS, and fourth is actually stack-oriented. All the old ones, like whenever you enter your, a lot of internet, JavaScript is a, maybe. No, never mind. Never mind. I don't know what I'm talking about, and please forgive me. But function-oriented programming languages meant that everything is ruled by functions. You don't have objects, unfortunately. Like, it doesn't, like, move around and call different objects. You're like, hey, we're making a rectangle, which just happens to be over here, and we're gonna use it over here. Function-oriented programming languages, normally they have one single file for anything they may do, and it goes top to bottom. Normally. They normally have one single file that is the brunt of their code, like they can't have objects in different files. They do have functions, however, so they can have like how I said, methods are like are called functions in some other languages. So basically, it'd be all up and down, and you can't go back and forth. So you have to have a function up top if you're going to use it later on. So you can't use like two methods that cross-reference each other. You have to go in down in the order that functions require, and it would all be in the front. Like after you declare all of your functions, and you'd have one little line of code, and then you'd have one like string of code below all of your functions about what it's actually going to do, instead of having like a main method like you have in Java, so you can like go different places and do different things. There's also agent-oriented programming language, which is actually cool, that I want to look more into, where instead of objects there are agents, which is kind of like agents, and different functions would talk to these agents, which also have artificial intelligence, which is a very cool aspect. So these objects would tell the agent, hey, I promise I'll do this, or I'll probably do this, or other things, or I'll dedicate these resources to you and the system, and other things. I mean, it sounds quite enticing, but yeah, I want to look into that. And there's stack-oriented programming language, which I said the old language of Forth uses, which means whenever you run something, it goes into the stack, which that means the whole operating system has a stack loaded, which contains integers, and I think it can contain strings. I'm not sure, but it contains integers, and in order to when you add an integer, it goes to the top of the stack, and the only way to access integers or any other variables are to access it in the stack. And you can't like call a certain index in the stack. You have to go through the entire stack so you have to discard everything off the top of the stack until you get to that part of the stack, the thing you want. So obviously it's a bit cumbersome and such. And there's several other orientations. You can look them up to your own free will. But that was a nice discussion, in my opinion. Well, I guess it's time to actually wrap up, unlike I did properly in the previous episode. But thank you for joining me and learning the basic concepts behind object-oriented programming language. And I will see you next time, where I think we can get into some other stuff. Yet to be determined. But again, have a great day, and I'll see you next time.